discuss about sparse matrix. Let us see sparse matrix. See here, anyone can answer my question. What is meant by sparse matrix? Please message in chat box. Don't speak. I'm using mic. I'm not able to hear you. Please message in chat box what is meant by sparse matrix. Already we have discussed in previous class, right? Anyone? Please answer my question. Students, already in previous class we have discussed about sparse matrix. What is meant by sparse matrix? No one is answering my question. I won't continue. I'm sorry. Students, no one knows the answer of sparse matrix. Students, is it audible? Is my voice is audible? Please respond. Is my voice is audible? Message in chat box. Students, is my voice is audible? Okay, only 40. Only roll number 40 is answered. Remaining members. What about remaining members? Is my voice is audible? Students, is my voice is audible? Is it okay? Only roll number 40 is there in the class. What about remaining members? Okay. Okay, let us continue. Sparse matrix. See here, sparse matrix means it is a matrix which contains most of the elements or zeros. It is called sparse matrix. See here, see the example, you will understand. See, most of the elements are zeros, right? If a matrix contains most elements zeros, then it is called sparse matrix. See the example. It is 4 by 4 matrix. That means 4 rows and 4 columns. Okay. Now here see here how many non-zero elements are there? 2, 4, 1, 3, 9. 1, 2, 3, 4, 5. 5 non-zero elements are there and most of the other elements are zeros only. So it is called sparse matrix. Now if you want to represent this sparse matrix in memory, how will you represent this how will you represent the matrix? Matrix is nothing but data which is arranged in table format, rows and columns, right? If you want to represent the data which is presented in table format, nothing but rows and columns, matrix. If you want to represent this matrix in memory, how to represent? You need to use 2D arrays. Okay, remember that 2D arrays. I will discuss about 2D arrays later. Now let us see what is the problem with the sparse matrix. Already we have discussed in previous class, but I will repeat it again. Now let us see what are the problems of this sparse matrix. See here, remember that this sparse matrix is represented using 2D arrays, two-dimensional arrays. Okay, it will be in this form. Something, for example, think this array name is A, like this, A of 4, next 4. This first, here you need to see, if you want to represent 2D arrays, you need to use array name. Here array name is A. And next two subscript, see remember, if you want to represent 1D array, one dimensional array, you need to use one subscript operator. If you want to represent 2D arrays, you need to use two subscript operator. Subscript operator is nothing but, 1 second. See, subscript operator is nothing but open square bracket, and close square bracket. So in 2D arrays, you need to use two subscript operators, open square bracket and close square bracket, together called subscript operator. So here array name A of 4, 4, because see here 4 by 4 matrix, right? Here first 4 means row size, next 4 means column size, row size by column size. Okay, I hope you understood. If you want to represent one dimensional array, just use one subscript operator like this. If you want to represent one dimensional array, this is one dimensional array, right? See here, this is one dimensional array, 0, 1, 2, 3. These are indexes, 4, 2, 1, 3, something like that. See, if you want to represent this one, one dimensional array. How to represent one dimensional array? A of, see what is the size? 1, 2, 3, 4. 4. Only one subscript operator. Remember that. Okay, let us go to the sparse matrix. These are basics already you have learned in your previous semester C language. I hope you all know this. Okay, now let us see sparse matrix. Let us see it. See here. See, there are two sparse matrix. What is meant by sparse matrix? Which contains most of the elements or zeros. And remember that if you want to represent this matrix, just matrix, if you want to represent this matrix in memory, you need to use a 2D arrays, a two-dimensional arrays. Now, see, there are two sparse matrices, just like this A, some another sparse matrix, where most of the elements of 0. Now, if you want to perform addition, if you want to perform addition, subtraction, multiplication, all those things, arithmetic operations, if you want to perform all these things on sparse matrix, see, most of the elements are zeros, right? See, for 0 plus 0, 0 only. And 0 minus 0, 0 only. 0 into 0, 0 only, right? So, most of the time is wasting, right? Because sparse matrix contains most of the elements of zeros. So if you want to add two zeros, you will get 0 only, you know that. And if you want to subtract two zeros, you will get 0 only. And if you want to multiply two zeros, you will get 0 only, you know that. But here most of the time is wasting. Okay, you know that 0 plus 0, 0, 0 minus 0, 0, 0 into 0, 0. Why to multiply it? Why to subtract it? Why to add it? 0 only, right? Answer is 0 only. So there is a solution for this, because here most of the time is wasting. And to store zeros, 0 is nothing but nothing, right? 0. If you no need to store 0. Okay, most of the space is wasting in memory, and most of the processing time is wasting for adding zeros. So here there are two solutions to represent this sparse matrix in memory. Okay, let us see it. Then representing this sparse matrix using two-dimensional array, there are two solutions for this, so that most of the time will not be wasted, and most of the storage space for zeros will not be wasted. Okay, let us see it. Let us see it. What are the solutions for representing this sparse matrix in the memory? Let us see it. Okay, solutions. First solution is triplet representation. Triplet representation. Here, this is also matrix only. Okay, this is also matrix only, but in triplet representation, this contains only 3 columns. 3 columns only, fixed. 3 columns only. This is also a matrix. Okay, triplet representation is also matrix, but this matrix contain only 3 columns. And row size, let us see row size. Number of rows will be row size equal to number of non-zero elements plus 1. Okay, see in this matrix how many non-zero elements are there. See the first row, how many non-zero elements are there? 1, 2. Okay, 2, 4, 1, 3, 9. How many? 1, 2, 3, 4, 5. So number of non-zero elements are 5. 5 plus 1. 5 plus 1 means 6. Now in triplet representation, the columns are fixed. Only 3 columns. And coming to rows, how many rows will be? Number of non-zero elements in sparse matrix. See the sparse matrix A, matrix A. See here, 1 non-zero element. See, I have rounded it. See here, 2, 4, 1, 3, 9. Come row wise. You need to see row wise. Okay. How many elements? 1, 2, 3, 4, 5. 5 plus 1, 6. So, number of rows in triplet representation is 6. Now, let us see it. Let us see triplet representation. Remember, how many rows? 6 rows. How many columns? 3 columns. Let us see it. Okay, now see here. Yes, 3. See the triplet representation. I'm drawing 3 columns, right? 3 columns fixed. 3 columns fixed. How many rows? Just now we have calculated number of non-zero elements. 5 plus 1, 6. So 1, 2, 3, 4, 6. 6 rows. How many rows? Just 1, 2, 3, 4, 5, 6. Okay. 6 rows, 6 columns. Now see here. Here first row. See first row. First row in triplet representation. It contains information about the matrix. Okay. See in triplet representation, first row in triplet representation will contain the information of the matrix. Here it contains a row size, column size, and how many values are there. See first I'm talking about this one. See here. In triplet representation, first row will contain information about the matrix. See, coming to the matrix, what is the row size of the sparse matrix? 4 by 4. See here, this is row size. This is column size. 4 by 4 column size. Now, total how many rows are there in sparse matrix? Write down rows here. See here, I'm writing. See in triplet representation, I'm writing. Next, how many columns are there in sparse matrix? Total columns, 4 columns. Next, how many non-zero elements are there in sparse matrix? See, 1, 2, 3, 4, 5, 2, 4, 1, 3, 9. These are non-zero elements. How many are there? 1, 2, 3, 4, 5. So write down 5. I hope you understood. See, first one is nothing but total number of rows in sparse matrix. Second one is nothing but total number of columns in sparse matrix. Third one is nothing but total number of non-zero elements. First row contains information about matrix. Info about sparse matrix. Sparse matrix. Now, here what you need to do is, see the third column in triplet representation. What is the third column value? First column is a row, the second column is column, third column is value. Now see here, what I'm doing is, first I'm writing all the non-zero elements. Come row wise. In C, first row, what is the non-zero element? 2, right? Write down 2. Okay. Next come to the second, this one. See, sparse matrix. See this sparse matrix 0, 0, 2, 0, 0, 4, 0, 1, that one. Okay. Now see here. Next, come to the next row. What are the non-zero elements? 4, 1. Write down 4, 1. See the triplet representation, right side one. Now come to the left side one. What is there in left side? Sparse matrix. Next, come to the next row. What is the element present in the next row? 3, right? Non-zero element 3. Write down 3. In triplet representation, I'm talking about third column in triplet representation. Third column represents value. You need to write non-zero values. One by one, come row wise. Okay. And remember that first row in triplet representation contain information of matrix. Okay. Now write down 9. Okay. Now what you have to do is, 1 second. Just wait. Just wait 1 second. Okay, see here. Just wait for 1 second. Now see here. Now here, see the triplet representation. What you need to write in row? See, you have written 2, 4, 1, 3, 9. All non-zero elements you have written, right? Now you need to write. Come to the second row. Second row in triplet representation. What you need to write is, you need to write row index of value 2, and here you need to write row index of column value 2 and column index of value 2. Now let us see the sparse matrix left side. See, I'm writing indexes. Index always starts from 0, 1, 2, 3 row index and column index. See here, see sparse matrix left side one, 0, 1, 2, 3. Okay. Just you have to write row index. Remember that row index starts from 0, 1, 2, so on. And column index starts from, this is row index. Row index. Row index. and this is column index, call index. Okay, column index. See 0 1. Now see here, see the non-zero element 2. What is the index, row index of non-zero element 2? See here, this one. What is the row index of non-zero element 2? 0, right? So write down in triplet representation. See the right side one. I am writing 0. Okay, see the triplet representation 0. And what is the column of value 2? See here, what is the column of value 2? This one. What is the column index of value 2? 2, right? See the arrow mark. 2. Write down 2 here. In the same way, find out row index of value 4 and find out column index of value 4 and write down. And in the same way, find out the row index of value 1 and column index of value 1. Value 1. I hope you understood. See here, I am writing. Please try to understand. For value 4, row index is 1. Okay, column index is 1. See the triplet representation. I am writing. Next, coming to value 1. What is the row index of value 1? This one. This one. 1. 1. And what is the column index of value 1? This one. See here. 3. 3. And coming to next row. What is the row index of this one? This one. Row index of value 3. See, value 3 is this one, right? Okay. 2. I hope you understood. Next column index is 2. Next, coming to 9. See the 9 here. What is the row index of value 9? 3. 3. What is the column index? 3. I hope you understood. Is it clear, students? Or shall I explain it again? Okay. Students, is it clear? Are you confused? Are you getting confusion? Or is it okay? Please respond. Is it clear? Is the concept is clear? Or shall I explain it again? Clear. Okay. Only Pranita is responding always. Okay. This is very easy. I'm explaining slowly. Okay, now let us see. See, first solution is triplet representation. This is completed. Now, let us see how to represent this sparse matrix using linked list. There are two solutions to represent sparse matrix. First one is a triplet representation. Second one is linked list representation. Let us see the linked list representation. Let us see the linked list representation. Okay, let us see it. Just 1 second. Please wait, students. I'm erasing. Please wait. Okay, let us see it. Okay. Now, linked list representation. Next solution is linked list representation. 1 second. Okay. Yes. See. Linked list representation. Okay, now see here. See, each node, to represent this sparse matrix, each node contains 4 fields. Each node contains 4 fields. Listen carefully. First field is row index. Second field is column index. Third field is value. Fourth field is next, which is a pointer which contains address of next node. Okay, students, see linked list representation, node representation. See the diagram. Each node in the linked list. Okay, to represent this sparse matrix using linked list, each node contains 4 fields. First one is a row index of non-zero element. Second one is call. That means column index of non-zero element. Next one is val. Val is nothing but value, non-zero element. Next is a pointer which contains address of next node. That means it points to the next node. If it is pointing to next node means this next field contains address of next node. Okay, this is a pointer. Okay, now let us see. I hope you understood. This is a node representation. Now, if you want to represent this node in memory, okay, if you want to represent this node in memory, how to represent this node? Anyone can answer my question? Please answer my question. how to represent this node in memory? Please students, please answer my question. See, no one knows. Already you have completed linked list insertion, deletion. Okay, already completed, right? Already we have seen the algorithms. You don't know? No one knows how to represent this node in memory. What you need to use? See, no one is answering. See, already insertion, insert at beginning, insert at end, insert in middle, deletion operation, searching operation completed. Up to now, you don't know the basic thing. Roll number 6, roll number 8, roll number 10. Please message. Students, say I won't continue. You don't know the basic thing. This is the basic thing, right? Linked list, madam. No. How to represent this node in memory? What you need to use? Yes, this linked list, you need to represent this linked list in memory, right? See, if you see matrix, how to represent matrix in memory, you need to use two-dimensional array. In the same way, if you want to represent linked list in memory, what you need to declare? What you need to use? Pointer. No. See, up to now, you don't know the basic thing. Students, roll number 10, roll number 8. If you want to represent this linked list in memory, first, what you need to use? What you need to declare? Answer my question. This is a basic thing. Without this, you can't write the algorithm. You can't implement this, right? See, no one knows it. Okay. You need to use structures. Already I have discussed struct, node. No one knows it. Please try to understand struct. See, if you want to represent this linked list in memory, you need to use struct. In C language, in C++, you need to use class. See, all these are basic things. Okay, see here. If you want to represent this linked list or this node in memory, you need to use struct. Structures. Okay, structures. How to declare a structure? Struct keyword space structure name. Here I am using node. Struct node. Open flower brace. See how many fields are there? 4 fields, right? Row, column, value. Next, see here row is nothing but it is a value, row index, which is an integer, right? See here 0, 2, all these are integers, right? So declare like int row semicolon. Next, what is the next field? Call, which contains a value only, right? Which value? Index, column index. So what is the data type? See, all these are integers only, right? Int call. Okay, next field. What is the next field? Value. Okay, what is the next field? Value. What is the data type? Value contains some integer only, right? Int val. Next, what is the next field? See here. What is the next field? Next, which is a pointer which contains address of next node. So what is the data type of it? Struct node only, because it is pointing to next node, right? 1 second, students. Okay, so struct data type, struct, it is pointing to another node. So declare like struct node. It is a pointer, right? So keep space star next. It is a pointer. If you want to represent pointers, you need to place star symbol before the variable name. I hope you understood. Close the flower brace and you need to use head, right? Star head semicolon. Using this head only, you can access a row, column, value. Next, how to access it? Head of row. See, what is this head? It is nothing but structure variable. Remember this. Here inside the structure, see what are the structure members. See, the variables inside the structure are called structure members. These are the basics. You need to understand. Okay, the variables which are present inside the structure are called structure members. Here, what are the structure members? Row, call, val, and next are the structure members. If you want to access this row, call, val, next, you need to use structure variable. See, what is a structure variable here? I am using a pointer. Star head is nothing but it is a structure variable. Using this structure variable only you can access row, call, val, and next. How to access it? You need to use structure variable name head arrow mark row, head of call, head of value, head of next. Okay, I hope you understood, students. Is it clear, students? Are you able to understand what I'm saying? Shall I repeat it again? Please message in the chat box. Is it okay? Is, is the concept is clear for you? See, this is a basic, students. If you want to represent this node or linked list in memory, you need to use structures. You need to declare a structure. How to declare a structure? See the screen. Students, is it clear? Shall I continue? See, I'm explaining very slowly. Is it clear, students? Is it clear? Is the concept is clear? Yes. Only roll number 8, 36, 3. Yes, okay. Please respond. Okay, thank you. Okay, now let us see how to represent this one, this sparse matrix using linked list. Let us see it. 1 second. Okay, let us see it. See, if you want to represent in linked list, first write down, what is this? 1 second. Mm. Just write down the triplet representation so that it will be easy for you. Okay, it will be easy for you to represent in linked list. If you just roughly you can note the triplet representation, it will be very easy for you for linked list, for drawing the linked list. Just roughly note down triplet representation. Okay, now let us see here how to represent. This is first row, first column, first row, second row, third row, fourth row, fifth row. Okay, you need to use these rows values, first row, second, triplet representation. See, if you are drawing the linked list, first roughly note down the triplet representation so that it will be easy for you to draw the linked list, because you need to know non-zero values and row index and column index of that non-zero values. Okay, now let us see each node in the linked list contains 4 fields, right? Let us see it. 4 fields. First, 1, 2, 3, 4. Okay, see, first field name is row, which contains row. What is this? Row index. Next field name is call, which contains column index of non-zero value. Next one is val, which contains non-zero value. Next one is next. Okay, next one is next. Okay, students, is another voice is overlapping? Madam is saying the class here. Other madam is saying the class here. Is madam voice is overlapping with my voice? Please message here. Is it clear? Okay. So other ma'am is saying class here. Okay. Now see here. See first row in triplet representation. See first row in triplet representation. What is the row index of non-zero value 2? See here. See non-zero values are 2, 4, 1, 3, 9. See the triplet representation. See this one, this column, row. See here, 2, 4, 1, 3, 9 are non-zero elements. First you need to write, see, first non-zero element is 2, right? Write down the row index and column index of 2. This one, I'm speaking about this. See the triplet representation. 0, 2, and what is the non-zero value? 2. And next contains address of next node. Now, what is the next non-zero value? 4, right? See the triplet representation. Using this triplet representation, you can draw easily. Just if you want to draw linked list, roughly note down the triplet representation and see all non-zero values. First two is completed. Next, what is the non-zero value? 4, right? What is the row index of 4? 1, 1. Column index is 1. Write down 1, 1, 4, and next. Just, okay. There is no space. That's why I'm writing like this. Please understand. Try to understand. Okay. Next, what is the non-zero value? See the triplet representation. Next non-zero value is 1. What is the row index of 1? 1, 3. Write down 1, 3, and non-zero value is 1. Next one. Next field contains which points to next node, which contains address of next node. That means it points to next node. Next, what is the non-zero value? 3, right? Next non-zero value is 3. What is the row index of row index and column index of 3? 2, 2. Write down row index of 3, row index of 3, and column index of 3, and non-zero value is 3. Next field contains address of next node. See, don't draw like this. Here there is no space. That's why I'm drawing like this. Next one is okay. Now see here. Next non-zero value 9, right? What is the row index of 9? 3. Column index of 9? 3. 3, 3, 9, and this is the last node. There is no non-zero values. So last next field must contain null. Null represents nothing. There is no another node. I hope you understood. In this way, you need to represent linked list representation. Each node contains 4 fields: row index, column index, value, and next. Next field, which contains address of next node. Is it clear, students? Shall I move to the next topic? Is it clear? Shall I move to the next topic? This is very, very easy, but you need to understand it. Shall I move to the next topic? Okay. Okay, now let us see the algorithm. See, before discussing about algorithm, I need to say some basics. Already you have learned in C language in your previous semester. You know all these things, but please try to listen it. You know all these things, but see, before before explaining the algorithm, you need to know some basics. I'll explain that basics. I will take some time. Okay, I have to take some time for this. I will explain the basics first. Just wait for 1 second. Wait for 1 second. Okay, now let us see it. See here. Now there is a matrix. First, see, I'm explaining some basics. I'm not explaining the algorithm of sparse matrix. First, if you want to understand the algorithm of sparse matrix, you should have some basic knowledge on matrices. Now see here, matrix. I'm taking some 1 second. I'm taking a matrix like 1, 3, something, 2 by 2 matrix, 2, 4, something like this. This is a matrix, 2 by 2 matrix. Row index will be 0, 1. Column index will be 0, 1. This is nothing but a row index. See, I'm explaining basics. I'm not explaining the algorithm of sparse matrix. This is column index. Call index. Okay. Now, see here. If you want to represent this table is nothing but which contains table of data, which is nothing but which contains rows and columns. Data is represented in a matrix format. If you want to represent this in memory, you need to use two-dimensional arrays. What you need to use? 2D arrays. 2D arrays. Now, how to declare it? You need to declare these two-dimensional arrays, right? How to declare it? Let us see it. Declaration. See, you know all these things already. You have learned in previous semester C language, but again listen patiently. You know all those things, but I have to explain it. Declaration. Okay. Declaration. See how to declare it. See, already I have discussed, right? If you are using two-dimensional arrays, means you need to use a two subscript operator. Inside that subscript operators, you need to pass or you need to place row size and column size. See here, subscript operator is nothing but open square bracket, close square bracket. It's called subscript operator. You need to use two subscript operators for 2D arrays. Now let us say I'm declaring data type space array name. What is the array name? A. Now see the first, this one first subscript operator. What you need to place? Row index. Here row index I have placed as 2. Next subscript operator, what you need to place? Column index. I have placed as 2. That means A of 2, 2 is nothing but 2 by 2 matrix. Row size is 2, column size is 2. Now, if row size is 2, remember that index starts from 0 to row size minus 1. 2 minus 1, that means 0 to 1. See here, see the left side diagram. 0, 1. Now see the column index column size. Column size is 2, this one. See the right side one. Column index is 2. That means row size begins from, sorry, row index, sorry, column index, right? I'm speaking about column, right? I'm sorry. See, column size is 2. Okay, column size is 2. That means column index starts from 0 to column size minus 1. What is the column size? See, this is column size. See the right side part, this is row size. Okay, always remember that index starts from 0 to size minus 1. Okay, I hope you understood. Okay, this is the declaration. Now let us see how to access each and every element. See, without knowing this, you cannot understand the algorithm of sparse matrix. Remember that for two-dimensional arrays, you need to use two subscript operators. Subscript operators are nothing but open square bracket and close square bracket. Now let us see how to access. How to access elements. Elements in 2D array. 2D array. Let us see the syntax. Let us see the syntax. See, if you want to access elements, what is the syntax is you need to use array name. For example, array name is A. Okay, array is two-dimensional array, 2D array. Now array name, you need to use array name. See, array name and two subscript operators. Two subscript operate. Now see here, I want to access value 4. See the left side diagram. I want to access value 4 of two-dimensional of matrix. Okay, of matrix. Okay. Now, if you wanted to access value 4, what you need to do is array name. What is the array name? Now, see here, accessing element of 2D array. See the right side one. A, array name. What is array name? A, subscript operators, two subscript operators. In first subscript operator, you need to place in row index of value 4. See here. Now see the diagram matrix. See the matrix left side one. What is the row index of 4? See here, row index of 4, 1, right? Now place in first subscript operator, place row index. Now see right side one, accessing elements of 2D array. In first subscript operator, place. Here you are accessing element 4. If you want to access element 4, if you want to access element 4, in first subscript operator, place row index of element 4. What is the row index of element 4? See the matrix here. See the left side part. Okay, row index is 1. What is the column index? See, this is a column index. Column index of value 4 is 1. A of 1, 1 is nothing but 4. I hope you understood. Now, if you want to access value 2, see here, if you want to access value 2, a of two subscript operators, in first subscript operator, you need to place a row index of value 2. What is the row index of value 2? See the matrix. Row index of value 2. See the matrix. Left side 1. What is the row index of value 2? 1. So place 1. Now, in next subscript operator, what is the column index? This is the column index of value 2. What is the column index of value 2? See the matrix. column index of value 2 is 0. A of 1 0. That means first row 0th column, first row 0th column element, first row 0th column element is 2. Okay, I hope you understood. In this way you are going to access the two dimensional arrays. Is it clear, students? Is it clear, students? Is it okay? Have you understood? These are the basics, students. Students, see, no one is responding. Is the concept is clear? Okay, now let us see. Now, okay, let us see it. One second. One second, just wait. Okay, now if you want to access the one second, just wait. I will draw the matrix. 1, 2, 3, 4. 2 by 2 matrix. Row index is 0, 1. Column index is 0, 1. This is I. This is J. This is J. Okay. Now let us see in programming language how to access each and every element. See, in two-dimensional array you need to use two for loops. Okay, two-dimensional array programming language. I'm explaining programming language. Now if you want to use two-dimensional array, you need to use two for loops. If you are using one-dimensional array, you have to use one for loop. Okay, now let us see. For okay, no, not this. For, see, in first for loop you need to use row index. Row index starts from 0, right? Here I am using I, which represents row index. Row index will start from 0. I equal to 0. I less than m. M is nothing but row index. Row size, sorry, row size. I plus plus, nothing but to take 2. Okay, okay, wait, just wait, I will explain. Next inner for loop represents a column index J. Take J equal to, you know that column index starts from 0 to size minus 1, right? See, J equal to 0, semicolon J less than n. N is nothing but column size, call size. N is nothing but call size. See, you know that index starts from 0 to size minus 1. Here I took less than n. Less than n is nothing but size minus 1 only, right? J plus plus. Now if you want to access elements, see, I'm printing printf percentage d. In the place of percentage d, value will be printed. See, if you want to print the values present in a variable, you need to use percentage d for integers. Now, which value you need to print? A of, already I have explained how to access. You need to use two subscript operators. First, okay, two subscript operators. Before two subscript operator, you need to place array name. What is the array name here? A. A of, first must be, in first subscript operator, you need to place row index. Here you are using I, right, for row index. Next, J. You are using J for column index, right? A of ij, that's all. Close the brackets. Okay, now I will explain tracing. Okay, I will explain tracing. Now see here, initially I value is 0. See, now control comes to I equal to 0. Now I value is 0. See here, I is pointing to 0. Next, control goes to check condition. What is condition? I less than m. M is nothing but 2. 0 less than 2. True, right? When this is true, control goes to inner for loop. J equal to 0. Now J is pointing to 0. See the matrix. I is pointing to 0. J is pointing to 0. After that, control goes to check inner for loop condition 0. What is J? 0 less than n is 2, right? See here, this is m. This is n. Okay. 0 less than 2, true, right? When this is true, control goes to inner for loop statement. What is that? Printf percentage d. In the place of percentage d, what will be printed? A of I value 0, j value 0. A of 0 0 means which one? See here, see the matrix. A of 0 0, see the matrix. Zeroth row, zeroth index, row index, and zeroth column index. What is that value? 1. 1 will be printed. I hope you understood. Okay. See, if you want to print in matrix form, give slash t and slash and all those things. Okay. Now see here, after executing this, control goes to check inner for loop. Okay, see here, I value will be 0 only. When I value will be incremented, inner for loop must be executed completely. After the inner for loop condition is false only, then only control goes to I plus plus. Okay, now see here, later trace out, you will understand. See, first I will be 0 only, now j will be 0. After that, see the matrix, see the matrix. One second. See this matrix. Initially, I value will be 0. Next, j value will be 0. 1 will be printed. Next, j plus plus. Okay, see here. Inner for loop will be executed completely. Control will be in inner for loop only. After the inner for loop condition is false, then only control goes to I plus plus, outer for loop. Remember that. Okay, now 1 will be printed. Now j will be j plus plus. Okay, 1 less than 2. 1 less than 2. See this one. Okay, please try to understand. Now 2 will be printed. After that, there is another. After that, this inner for loop condition will be false. Now control goes to I plus plus. When inner for loop condition is false, control goes to I plus plus. Now I will be incremented. Now I will be pointing to 1. Now you will be print. Now j will be 0. Okay. After incrementing, again control goes to inner for loop, right? Now j will be 0. Next, 3 will be printed. Next, again j will be incremented. Remember, I will be 1 only. Inner for loop must be completely must be executed. When condition is false only, I goes to I plus plus. I will not be incremented. I will be 1 only. Now j will be 0. After that, j will be incremented. J will be 1. Okay, there will be condition check. I'm not saying all those things. Already you have learned in previous semester. Okay, j value will be 1. Now 4 will be printed. Now next I will be incremented. Okay, see here, I is pointing to 1, right? Now I will be incremented. Control goes to here. I will be 2, right? 2 less than 2. See the condition. 2 less than 2, false, right? Now control comes out of the loops. I hope you understood in this way. What is this? Okay. In this way, execution will take place. Please trace out. You'll understand. Okay, already all these topics are completed in your previous semester. Already you have learned in C language. Okay, now let us see sparse matrix representation algorithm. Okay, let us see it. What is this? Oh, 1 second, students. PPT is closed. Just 1 second. Okay, did you understand? Students, did you understand what I am saying? What I have explained right now? Students, please respond. Have you understood? Students, no one is responding. Have you understood or not? These are basics. Without these basic concepts, you cannot understand the algorithm. No one is responding. Okay. Okay, I'll continue. '53. Okay. Okay, let us see. Just wait. Okay, algorithm I will explain next class. Just see again. Linked list representation. How to represent the linked list node. Sorry. How to represent a node of a linked list. See, there will be four columns. Sorry. There will be four fields. First field is row field. Second field is column field. It's nothing but it contains a row index. Next field is col, which contains column index of non-zero value. Next field is value, which contains non-zero value of the sparse matrix. Next field is a pointer, which points to next node. Now, how to represent this node in memory? How to represent this node in memory or linked list in memory? First, you need to declare a structure, right? Struct node. See the structure members. See, I'll explain algorithm in next class. Time is completed, right? Only 5 minutes are there. I will explain algorithm in next class. Uh, Students, please refer two-dimensional arrays. How to access each and every element, and how to initialize the two-dimensional array. Okay. Please refer the C language notes or some material or textbook. Okay. Before coming to the next class, I request all the students to see the programming language, C language, two-dimensional arrays, how to access it. You need to use two for loops, how to initialize the array. Okay, you should know all these things. Before coming to the next class, I request all the students to see that. Okay, now let us see struct node. See, row, call, val. Next, all these are called structure members. Structure members. Int row, int call, int val. See here, row, call, val, all these fields contains integers only, right? So int, that's why I have declared as int. Next, see here, next is a pointer which contains address of next node. Which node address? Next node only, right? So what is the data? What is the type of that node? Struct node only. So struct node space next. Next, star head. What is this? This is a structure variable. See, all these are basics. Without knowing these basics, you cannot write the algorithm. Structure variable. Using this structure variable only, you can access the structure members like row, call, val, next, all these things. Initially, head will be null. Initially, head will be null. In this way, you have to represent the linked list representation of sparse matrix. Okay, first one is a row index. 0 is a row index of which one? Of non-zero value 9. 4 is a column index of which one? Of a non-zero element 9. Okay. Next, you need to you need to insert non-zero value 9. Next, I hope you understood all this already. I have explained. Students, in next class, I will explain the algorithm. Before coming to the class, what you need to do is you need to see the 2D arrays. 2D array, how to access each and every element in 2D array, how to initialize and how to access each and every element in 2D array. Refer C language textbook. I request all the students to refer that, and also refer insert creation algorithm creation algorithm of single linked list. Before coming to the class, what you need to do is these two things. Refer these two things. Without understanding these two things, you cannot understand sparse matrix creation algorithm. Okay, before coming to the class, please refer 2D array, initialization, and accessing, programming language, C language, and also creation algorithm. Once again, see the algorithm of creation of single linked list. Okay, then only you can understand this algorithm of sparse matrix. In the next class, I will explain it. Okay, students, any questions, any doubts? Students, is it clear? If there are any doubts, please respond. Okay, students. No doubts? Okay, thank you, students.